Hey guys, welcome to Geometry. This video is supposed to be the lesson for March 10th and March 11th. So A day and B day, March 10th and March 11th. I haven't been in school. I wasn't in school last week and I won't be in school this week either. Something unexpected happened in my personal life, and I'll let you guys know more about it when I get back. I should be back. I will be back after spring break. Miss you guys and everything. So let's go ahead and jump into the lesson. So the lesson for today is going to be 14-2, which is angles in inscribed quadrilaterals. But before we jump into this paper, I wanted to talk a little bit about some of the other papers. So if you go to Focus and you check your grade book, go to Focus and you check your grade book, these are the papers that I'm looking for. There's 13.1, which looks like this. So something like this. 13.1. There's 13.2, which is sine and cosine ratios. That one is another one that is due. The special right triangles, that one looks like this. This one is also due. The math lim, so if you did a math lim, that one is due. And then the review, so the review looks something like this. It says trigonometry unit test review. The papers, if you need them, they are located in my room, and the colorful drawers. So if you need them, you can find them in the colorful drawers. The one that I had you guys do, I wasn't there for it, was 14-1. 14-1 is central angles and inscribed angles. This one I'm gonna make it extra credit, so if you did this one and you turned it in, I had a few people turn it in, so if you did that one and you turned it in, that'll be extra credit. And then the one we're working on today is 14-2, angles and inscribed quadrilaterals. So obviously there's only so much that I can teach you guys, in a video form. So what I did was I on Canvas for this class, which you're on Canvas right now watching the video, which I'm currently filming, I haven't uploaded yet. The inscribed quadrilaterals quiz is, this one will help you more. So you click on it and then you can go work on the quizzes. This one will help you with the assignment, and if you complete this, obviously I'll give you some points. So you have until Saturday to get this done, because I just put it in there right now. All right, so 14-2, angles and inscribed quadrilaterals. As always, make sure that you put your name. Put your name. I haven't been getting very many papers with no names, so good job on that. Today's date, I'm doing this on Sunday, March 9th, but you guys will be either doing this on March 10th or March 11th. And then class period, you know what class period you're in by now. A day, first, second, or third. B day, 5th, 7th, or 8th. So you know what period you're in by now. So the main topic of today is about angles and inscribed quadrilaterals. So inscribed In, when you think of the word in, you think of like inside, right? So we're looking at quadrilaterals that are inside. Quad means 4, right? 4 sides. So we're looking at 4-sided figures that are inside of what? Well, they're inside of circles. So if you draw a circle, I know it's not perfect, but if you draw a circle and then you draw a quadrilateral inside, that's what we're talking about today. This is an editor's note. After I rewatched the video, I realized that I didn't really truly explain properly what I mean. You can draw any kind of quadrilateral inside of the circle, right? But that's not really what I'm referring to. I'm referring to a quadrilateral where all of the points, so call this A, B, C, and D, all of the points have to lie on the circle. So we're not talking about just one point on the circle and then the rest just randomly. We're not talking about that. We're not talking about 2 points. You know, we're not talking about this. We're not talking about 3 points. None of these are mathematically interesting to us. 0 points, 1 point, 2 points, 3 points. When we say inscribed, it means all 4 points touch. All 4 points touch the circle. Inside quadrilaterals. So the important fact about inscribed quadrilaterals is that their opposite angles are supplementary. Supplementary. Opposite angles are supplementary. So that means that the opposite angles add up to 180 degrees. So if you take a look at this figure that I just drew, what are the opposite angles? Well, let's say that this is A, this is B, this is C, and this is D. The opposite angles are A and C, right? And the opposite angles are B and D. So measure of A plus measure of C equals 180 by definition. And it's going to be like that for all of these. I've selected a few problems that we'll do together. We got 1, 5, 7, 8, and 10. So 1, 5, 7, 8, and 10. So each quadrilateral is in a circle. Determine the angle measures. A, B, C, D. So A is 53, B is 82. So we can draw ourselves a little picture. Here's a circle, kind of, more or less. It doesn't have to be perfect, and as a matter of fact, it's not going to be perfect, not even close. So A, this is A, B, C, D. So that means A is next to B, right? B is next to C and also next to A, right? So B is between A and C. So here's C. And then D, C is next to D as well as B. So that means that this has to be D. So A is 53. B is 82. So C, we know that A and C are opposite. And then B and D are also opposites, right? A and C are opposites, B and D are opposites. So that means that A and C add up to 180. So if I take 180 and I subtract 53, so then we take 180 subtract 53, so we got 0 subtract 3, we can't do that, gotta borrow. 10 subtract 3 is 7, 7 subtract 5 is 2, and 1 subtract 0 is 100. So that means that our angle C right here should be 127. And if you want to double check yourself, we've got Desmos Scientific. 127 plus 53 is 180. So that is what we wanted. 127. And then measure of angle D is a very similar process, but for 82 degrees. So we've got 180, subtract 82, 0 subtract 2, can't do that, gotta borrow. 10 subtract 2 is 8, 7 subtract 8, can't do that, gotta borrow. So we're looking at 17 subtract 8, that makes 9. So we end up with 98. Yeah, so that would be example number 1. I mean, if I were there in person, I would ask you if you have any questions. But since you guys are going to be watching this video on YouTube, you can leave a comment. If you have a question, I can do my best to answer it. Number 2 and number 3 are very similar. Look, this one even tells you that JKLM is 90 degrees. So J is 90. So what would you think about angle L, right? And then it says that K is congruent to M. So K and M are the same. So that's just a little bit of thinking question for you. All right. So let's take a look at number 5 now. So the number 5, 4, 5, 6, and 7 are asking to determine whether the quadrilateral can be inscribed. So it's if it can be inscribed or not. So what we are going to need to check is we're going to have to check the opposite angles. We're going to check the opposite angles. So look here at number 5. All right. So let's say I try to draw a circle around here. Does it work? So these two are opposites, and then these two are opposites. So if I didn't mention already, quadrilaterals add up to 360 degrees. Then we know that this one's 124 and this one's 90. So we've got 124 plus 90, and then this one right here is 58. So that makes 272. So 360 minus 272. Can do the math. 8. 260, so that'd be 5, 15, 8, 88. Did I do that right? Yep, 88. So that means that this one right here has to be 88. So let's just double check the opposite angles. So the opposite angles here are 124 and 90. So 124 plus 90, and then we've got 88 plus 58. So 88 and 58, I mean, you can do it by hand here, or you can do it on the calculator, whichever you prefer. 8 plus 8 is 16. 1 plus 8 is 9. Plus 5 is 46. 146. And then here's 4. 2 plus 9 is 11, so 214. So, what do you guys think? Do they add up to 180? Are they supplementary? 214 and 146. Well, if you said yes, you need to double check, because 214 is not equal to 180 and 146 is not equal to 180. If you said no, that it doesn't work, then you are correct. So it says determine whether each quadrilateral can be inscribed. So this is either a yes or a no. So here, we're just gonna simply write no. No, it cannot. So here's where I would ask if you have any questions. But again, if you do have a question about how I did something, type it in the comments, and I'll be able to answer you in the comments. Number 7 is the next one I promised we'd look at. So number 7 is a little different because it doesn't give us any angle measures. It just has a little symbol, right? So in our studies, we've looked at this symbol before. This symbol means 90 degrees, right? Right angle. It's a right angle, it's 90 degrees. So this is opposite, and this is opposite. So this one kind of looks like a kite, I guess. Kind of looks like a kite, like you're flying a kite. So now 90 and 90, last time I checked, 90 plus 90 equals 180. So these two are supplementary. These opposite angles are supplementary. But what about those two? What can we say about those two? I know you guys are watching on YouTube, so maybe take a pause and think about it. You might want to ask your partner what they think. Talk about it a little bit. But, so now that you've taken a little bit to think about it, remember that this is a quadrilateral, right? It's got 4 sides and 4 angles, and they add up to 360 degrees. So these angles don't have names, but let's say I called it L, M, N, O, right? So L, M, N, O. So if I take L plus M plus N plus O, I get 360, right? Seeing that this is a quadrilateral, you get 360. However, I know that L and N add up to 180. So if I take L and N, I can take away 180. So L and N, I'm left with M and O equals 180. So would you look at that? Even though we don't know what those two are, we know that they add up to 180 because those two add up to 180. So since those two add up to 180, those two have to as well. So the answer here should be a yes. All right. So I changed my mind a little bit. I said we're gonna do 8 and 10. I think we're gonna do 8 and 9 instead. So we'll do 8 and 9, because 8 and 10 are very similar. If you can do number 8, you can do number 10, but 9 is a little different. So we are going to do number 8 and number 9. Again, if you are looking on YouTube, if you have questions, you can go in the comments, and then you can write me a comment and I'll be able to answer. So number 8, this one is telling us to determine the angle measures, right? So we're just going to determine some angle measures here. We'll start out by taking a look which ones are opposites. So it looks like X and Z are opposites, and Y and W are opposites. So it looks like we know that Y is 8x plus 21, and then W is 7x minus 6. So if I take Y, measure of Y plus the measure of W, I know that has to be 180. Since those are opposite, they have to add up to 180. So since those have to add up to 180, let me do a little bit of substitution here. Y is 8x plus 21. W is 7x minus 6. We can do a little bit of algebra. This is turned into an algebra problem, right? So we know that the cat wants to say hi. So we know that 8x plus 21 plus 7x minus 6 equals 180. So 8x, 7x, those need to be combined. Positive 21 and negative 6 need to be combined. So 8x and 7x makes 15x. Positive 21 and negative 6 make positive 15. We can do a little bit of simplifying here. Looks like this 15 needs to get moved over. So opposite of positive 15 is a negative. Positive 15 minus 15 cancel out. 180 subtract 15 would be 100 and my brain's not working right now. 165. 165. And we would need to divide both sides by 15. Opposite of multiplying by 15 is dividing by 15, so those are going to cancel. And we're left with x equals 165 divided by 15, which if I'm doing my math right, I think that's 11. Yeah, 11. 165 divided by 15 is 11. So we end up with x equals to 11. Now, this x is not the same as this x right here. That's referring to angle x. So now that x is 11, we can figure out what y is, we can figure out what z is, and we can figure out what w is. So y is 8x plus 21. So 8 times 11 plus 21. Z is 10 times 11 minus 1. And W is 7 times 11 minus 6. So we can just plug all of those directly into the calculator here. 8 times 8 times 11 minus plus 21. That's 109. 10 times 11 minus 1. 10 times 11 minus 1 is also 109. What a coincidence there. So y and z are actually the same angle. And then W is 7 times 11 minus 6, which comes out to 71. So that means that y is 109 degrees. Make sure you put the little degree sign. Z is 109 as well. And then W is 79. Now, how would we figure out X? How would we figure out X? Good question. Because the question wants us to figure out X, even though we don't know anything about it. But that's not quite true, is it? Because we do know that X is opposite to Z. And what do we know about the opposite angles? Starts with an S. Opposite angles are supplementary. They add up to 180. So, X and Z are opposite. So if I take 180 and I subtract Z, which is what? 109. What do I get? 0 subtract 9, can't do it. 10 subtract 9 is 1. 7 subtract 0, 7. 1 subtract 1, 0. So we get 71 here. And remember, the opposite angles add up to 180. So you can double check. X is opposite to Z. 71 and 109 makes 180. Y and W are opposite. Y is 109, W is 79. They add up to 180. So, if you have questions about number 8, write it in the comments and I'll be able to assist you in the comments. I promised you guys number 10 originally, but I changed my mind, so I changed my mind to number 9. So let's do number 9. So number 9 actually utilizes what we learned in the central and inscribed angles. This one, this is the one I told you guys was extra credit because I wasn't there to give you guys the lesson for it. Which is why you might not know how to do this one. So this one, actually, as a matter of fact, none of the angles are told to you at all, right? So you might be thinking that this problem is impossible to complete. However, there is some very important information given by this picture. If you look carefully, we got this line segment CE right here. Well, that just so happens to be a diameter because it passes right through the center. That's a diameter. And then DF is also a diameter. So that means that essentially this is half of a circle. Exactly half. This is a semicircle. Okay, so this is a semicircle from here to here. And as a matter of fact, so is that from D to DCF, that's a semicircle. And as a matter of fact, so is this CDE, and so is CFE. They're all semicircles here. They're just cutting the circle in half, semicircles. Now, if you, the central angles and inscribed angles, again, I wasn't there to teach you guys about it, but this is 180 degrees of a circle right here. Semicircle is 180 degrees. So because the semicircle is 180 degrees, then take a look at this angle right here, angle C. Here, let me get a different color. So angle C, this creates this arc, right? This arc right here is created by this angle. This angle, or this arc, is 180 degrees. So this angle is exactly half. Half of 180, 180 divided by 2 is 90. That means that angle C happens to be exactly 90 degrees. So if angle C is 90 degrees, I take it that you'll be able to figure out the rest, because C is opposite to E and also D and F. That's right. They're all just gonna be 90. So, I've done 5 with you guys, but again, this doesn't replace hearing it in person. This doesn't replace the lesson that I normally give in class. Try your best, and please turn it in. Again, I'll see you guys after spring break. Be good for the sub. And I will have another video here. Once I make it, I'll upload it here for March 12th and March 13th. And I'll have another quizzes for you guys as well. That way you guys can stay ahead with your learning. And yeah, but if you do have any questions about anything, please leave them in the comments, because like I said, this will be a YouTube video and you guys can make the comments. And make sure that please turn in any missing papers. If you have any questions where the papers are, make a comment in the YouTube, and I'll be able to answer the comments. I'll see you guys.